Good morning, friends, and welcome to another exciting episode. In today's lesson, we'll still be looking at separation methods. However, we'll focus on just these two separation methods. So, one, looking at the use of separating funnels. Then we'll look at fractional distillation. Okay, so let's start by looking at the following important things. So let's look at what's miscible and immiscible solutions are, or immiscible liquids are. Okay, so let's take a mixture of, for example, alcohol or ethanol and water. When you mix these two items together, you have a mixture that is doesn't look alcohol and doesn't look water. Actually, you have a uniform mixture. So the two can mix together without you being able to tell which component of the mixture is alcohol and which component is water. Form a uniform mixture. Anytime two liquids, and the word there is liquids, mix together uniformly, that mixture is miscible mixture. And the liquids involved are called miscible liquids. So alcohol and water are miscible liquids because they can mix together uniformly to form a mixture. What about immiscible liquids? So let's take an example, oil, and again let's use water. When you mix these two together, the two this time wouldn't mix uniformly. Even when you shake them together after mixing them, you'd realize that the oil would always settle on top of the water. The reason is that they are not miscible, so they are immiscible liquids. So oil and water are immiscible. They do not mix uniformly together. Now, you can even have another example of immiscible liquids such as kerosene and water or petrol and water. For miscible or for the miscible side, you can have kerosene mixed with petrol. They will mix uniformly. Or petrol and diesel. When you mix them, a mixture will form a uniform solution. Or yes. So we understand what miscible liquids are. They are liquids that can mix uniformly. Whilst immiscible liquids are liquids that will not mix uniformly. They actually form layers when you put them together. So now let's look at another concept. And here we'll be looking at what a separating funnel is. The two separating funnel, how does it look like? So it's actually a funnel. So let me see if I can draw something. Actually a special kind of funnel. But the difference here is that this funnel has a tap. So let me put the tap here. So let's say let's put water in this funnel or any liquid in this funnel. We have liquid in this funnel. Now, this tap within the funnel or on the funnel allows you to regulate the flow of the contents of the funnel. So for example, I can close it, the tap, and when I close it, nothing will flow out of the funnel. I can open the funnel, the tap, and the liquid inside would flow out. I can even tune it, the tap, in such a way that the liquid will flow faster. Or I can tune the tap in such a way that the liquid will flow slowly and in droplets. So that's how the separating funnel looks like. Interestingly, it is transparent, so you can see through. So assuming I pour water or liquid, any liquid into the funnel, you can actually see through and be able to tell the level of the liquid in the funnel. So that's how a separating funnel looks like. So we know what separating funnel is, know what miscible liquids are with examples. We also know what immiscible liquids are with examples. So now let's look at the separation methods. We'll start with the situation where you have immiscible liquids. So you have a mixture of liquids that are immiscible. Example, so you have oil, it could be palm oil or any other oil, and water. Oil and water are immiscible because they will not mix together to form a uniform mixture. Remember, they are all liquid. So this mixture, how do I separate them? And please, I need you to note this. Anytime you have the situation where two liquids are mixed together, to separate them, you can always rely on the separating funnel. And I'm going to teach you how you can achieve this. So you use the separating funnel to separate a mixture of immiscible liquids. So you have a container. This container contains two liquids. So we have oil and water. So that's the water, and that is the oil on top. In fact, when you put the two together, they will not mix, they will form a layer. Usually the oil will be on top because it has a lower density, and the water will be at the bottom. So it will look like this. So this mixture, for me to separate it, all I will need to do is to pour this mixture into the separating funnel with the tap closed. So let's quickly see if we can draw something like that. We have the separating funnel here. A tap is here and it is closed. Nothing comes out of the tap or of the funnel. I'll pour the mixture into this funnel. So I'll pour it here. So you would have two layers. The first layer will be the water. It settles first because it has a higher density, sorry. Then we have the next level, which will be the oil. Remember, the tap is closed at this point. We have the oil, we have the water. Now, so all I would have to do is to regulate the tap such that or even before I do that, I can put a little container here to trap whatever comes out of the funnel. Then I can regulate the tap in such a way that the content or the mixture or whatever is in the funnel flows in droplets. It will come in droplets, and you are making it flow in droplets so it will be easy for you to monitor whatever comes out. So you are making them come in droplets. So you've opened the tap, contents are flowing in droplets. So what will be flowing now will be the water. So the water will start flowing, but in droplets. It will flow. Whilst it flows, all of the water will be flowing until you get to the point where you are going to have the first oil droplets. At that point, you can tell that all of the water had drained out of the funnel. So at that point, you close the tap. Remember, you allow the water to flow in droplets until you get your first drop of oil. At that point, water had flown out, all of it had flown out, and you are left with the oil in the funnel. You have separated the two. Water trapped in this container, whilst the oil would remain in the separating funnel. You just have a little drop, a single drop in the water, which you can easily take out using maybe a spoon or something. But that's how the separating funnel works. And it is always used to separate two immiscible liquids. Please, I need you to remember this. And it's as simple as that. Now, what if you have the situation where the liquids involved, they are miscible? So, for example, you have ethanol or alcohol mixed with water. In this situation, the alcohol and the water they will mix together to form a uniform mixture. That mixture or that yes, that mixture is a miscible mixture. How do you separate them? Can you still rely on the separating funnel to separate them? And I believe your answer is no. And it's no because the mixture is uniform. So it's very difficult for you to tell which component of the mixture is ethanol and which component of it is water. So there wouldn't be any layer for you to separate. So you cannot use the separating funnel to separate the mixture of miscible liquids. However, you can use another method. Now, and this is how the method, before we even talk about this method, let's think about it this way. Alcohol, let me ask you this question. Alcohol and water, do you think they will have the same boiling point? The answer is no, because they are different. And in fact, usually different substances have different boiling points. You can actually use boiling point to determine what substances are. So every substance with boiling point of let's say 100 degrees Celsius is usually likely to be water. Well, not all the case, but water would always have boiling point of 100 degrees Celsius, provided it is pure. And ethanol or alcohol would always have boiling point of 78 degrees Celsius. What it means is that alcohol would always boil first before water if you mix the two together and you heat the mixture, because you need a lower temperature to boil alcohol than that of water. Now, these properties of liquids mixed together, or you can make use of the boiling point to separate them. So let's see if we can apply this concept in separating the alcohol from the water. We have two different boiling points, remember. That's what we are going to look at. That's where the concept of fractional distillation comes in. I believe you remember distillation. We've done distillation in separation methods 1. Honestly, fractional distillation is not really different from distillation. The concept is the same. The only difference is that you would use fractional distillation when you are dealing with two liquids that are miscible. But the concept, it follows the same concept of evaporation and condensation. That's those two processes are the processes involved in fractional distillation. You evaporate the liquid, then you capture it by condensing it into the same liquid. That's how it works. So how does it work here? So let's put the two liquids together. So you have a mixture of water and ethanol. Remember, they mix together. So this is the mixture. All right, they are miscible. So you can simply pour this mixture in the fractional distillation tube or whatever you call it. So let me draw a tube here like that. So you pour the mixture here. Let's pour the mixture here. Of course, heat will be applied to this. You remember similar thing happened when we were looking at distillation. Now, once you apply heat to this apparatus, when the temperature gets to 78%, what would happen to the ethanol? It will start boiling. But remember, the water component of this mixture will not boil because water only boils or begins to boil at 100 degrees Celsius. So it is only the ethanol component of this mixture that will begin to boil. And remember, once something begins to boil, it evaporates. So the ethanol will begin to evaporate. Remember, at this point, the water is not boiling, so it's not evaporating. But of course, once it begins to evaporate, we would want to trap it somewhere. So let's create a route here where we can trap our ethanol. All of it will vaporize and will pass through this tube like that. I will look for a way. Of course, there will be a condenser somewhere here that would condense the ethanol into liquid ethanol for us to be able to capture it somewhere here. So the liquid ethanol will be captured here. Remember, all this while, the temperature of the heat applied hasn't gotten to 100 degrees Celsius yet. So which means that the water has not started boiling yet. Now, by the time the water or the heat gets to 100 degrees Celsius, all of our ethanol would have been captured, leaving behind the water. We can remove this container and put another container there. At this point, water has started boiling. Because water has started boiling, remember anything that boils will vaporize. That water would also start vaporizing. And we will follow the same process. Once it vaporizes, it will be captured in the condenser. Remember, once you get there, there's cold environment, so that water vapor would also be captured. And it would end up in the container here. You capture the water too. So that's how fractional distillation works. It works exactly in the same manner that the distillation works. Just that we use it to separate two miscible liquids that will mix together. That's when we use fractional distillation. Now, let me see if there is something else I would have to talk about. Now, with the diagram on the screen, of course, this diagram doesn't look nice. Just visit any textbook with fractional distillation, and you can get a proper diagram that you would even appreciate better. But please remember that you need to understand the concept, and that is it. Follow the same concept or principle of evaporation and condensation. Okay, so that's what fractional distillation means. And usually we apply fractional distillation extensively in the making of or in the ethanol or alcohol industry. So companies that produce alcohol use this method to produce alcohols. Then in those who work on crude oil being processed into kerosene, petrol and diesel. Remember, crude oil has a mixture of all of these things and all of them are liquids. So you have liquid petrol, liquid kerosene, liquid diesel mixed together with other liquids to form crude oil. To be able to separate them, you can use fractional distillation to achieve that. Why? Because petrol, kerosene and diesel have different boiling points. So they will all start boiling and vaporizing at different temperatures. By the time one is done and is captured, that's when the other would also begin vaporizing and that would also be captured. When you are done with that one, then this next one would also vaporize and you capture. That's as simple as that. So I believe that brings us to the end of today's class. Please share this video if you have not done so. Remember, sharing is caring, and you need to help your friends who are struggling in science and mathematics. So, again, if you've not subscribed to the channel, please do so. You need to encourage me to do more of these videos. Moreover, so that you would be able to get new updates, new videos once I make them. So that is it for today. Take good care of yourselves. We'll meet again in the next video. Bye bye.